Hello guys, today we are going to solve an interesting functional equation. So function from x plus 1 equals a term function x plus b term function x minus 1, where x is natural, and for natural x this is real. Well, how can we do it? Firstly, we don't need to find all the functions. We just have to find one function that satisfies this equation for a and b chosen. For common case of A and B. Okay, now let's try to do this. Firstly, let's suppose that this geometric uh, series, I mean function x plus 1 over function from x is a constant, and let's divide everything here by function from x, and we will get this constant only instead of functions, and we will get this constant. You can ask me what have I done. I will say we supposed f of x is constant time something at the power of x. It means this is equals this something, and this is the same stuff but with the negative one power. I'm going to call this d number. Okay, and you can see this quadratic equation which gives us two roots, and we will just write them, and we will get two functions, right? Right. Let's do this. Now you got it. We have two roots d, but you have one case where this square root equals 0. Then we have 1d because they equal to each other, right? Well, I will draw lines here because it seems so bad. Okay, let's call them d1 and d2. Then we have two functions, and these two functions are constant time d1 in the power of x and another constant time d2 in the power of x. Well, if we suppose everything here is correct, these two functions satisfy this equation. I'm going to check it. Wait a few seconds, please, or do it yourself. Well, if we do this, we are going to get right here, and then everything works. Well, but what if I say you two first numbers of this row? How do you call this? Of the sequence? Yes, the sequence. For example, f from 1 is u1, f from 2 is u2. Now seems like if we make this equals to u1, this may be not equal to u2, right? And this is bad. But what can we do? Our function is our function rule is not changing if we will sum these two functions. I mean, if we will set g of x equals to this function plus this function, it will be the same. Rule will be the same because check it yourself. It's very simple to understand. And what's now? Now we just have two variables and two equations, and this is the linear system of equations. 2 times 2, it has one or more solutions. For common case exists two solutions, or exists one solution. Okay, I will show why is it so. Now just note, this is a number. This O is number except C and D. They are variables. We don't know them. You can say it's a matrix expression, but if you know matrix, solve through them. I will solve without. Well, what can we do now? We can get C or get D, for common case, of course, I mean. Firstly, let's maybe cancel this. Well, let's leave it. I will multiply everything here by d1 and get the same here and here. Now they are almost equal, but these terms are equal. We can just cancel them and get new expression. Now you can simply get d from here because it's a linear function, right? Only one solution exists. And then move it right here, plug it here, and get c because it is the simplest equation from all them three. Let's try to do this. Okay, now we have d. Let's get c and say this is good place to stop. Okay, I'll copy my hello pen again. Seems like this, and then you plug d here. So yes, this may be a good place to stop, but I will finish it. I will say that there is this d2 which we can plug out of the division, and then we'll set the common formula. Since it is the final answer, but we have something to simplify there anymore. It is d2 minus d1 in the denominator. It is common, and this is the final formula for the common case. If you would like to find something for current and B, for example, the Fibonacci sequence, I will try. Wait, I made some calculations and I got that. If A and B equals to 1, Fibonacci sequence, right? You'll get D12 equals to golden numbers. Well, let's go next. Almost forgot to say that all this U equals to 1, 2, because Fibonacci sequence is 1, 1, 2, and so on. Well, I drew it. Seems quite creepy. Okay, let's try to simplify. For example, yes, I can simplify everything here. Well, numerator is done. This is minus 1, this is 1. But what's next? Denominator. This will be minus square root 5 minus square root 5 plus 1 minus 1, which cancels, and we will get minus square root 5. And seems like something interesting, but and now let's get rid of this minus in the denominator, seems because it seems quite bad. So where have you seen natural number with plus at the beginning? Clear it. Okay, and now let's open D1 and D2 here. I made them so shrinked because there is x power and nothing can cancel with them. And now wait, what is this? What is this junk? Yes, now it seems like something good. So if you try to open here by using the Newton's what? The Newton's binomial method, you will get everything here is rational and even integer. But seems like mostly rational, but as you can see, the Fibonacci numbers and first terms are integer. It will be everything here integer too. I will use Desmos to show you everything here is workable. So I used flow function because you know something here may be negative and Desmos doesn't work with complex numbers. Yes, I know it doesn't work. Well, this is our function with floor, of course. This is our u1 and u2, and this are our a1 and b1. And what is it? Fibonacci. As you can see, this has negative roots, but just wish they doesn't exist. Okay, goodbye. Subscribe my channel. Set like, type a commentary.